Clap. Video we are going to understand a very important question from the wiki contest 457. So we have already uploaded Q1, Q2 and Q3. So 3 questions we have uploaded and this is the last one, and it's a little hard marked question, but if you will understand the problem it will be easy for you, right? Because you already aware with a lot of things. So let's continue to understand. Okay, so the question is saying that minimum moves to reach the target in the grid, right? So you know the grid is look like a 2D map, right? And that is called grid, right? And there will be some points will be there, right? Let's suppose some points, let's suppose we'll call here, this is called source, and we have to reach here, right? So how we are going to reach, right? In that based question we have here, okay, means 4 points we have given, x, sx, sy and tx and ty. So this is for the source point. So 2 points we have given, this is called for, let's suppose for source, and this will take for target, right? So as we have discussed here, right, this is source and this is target. Okay, so we have given 4 integers, these integers we have given, and it represents 2 points, x and s and t. And this grid is very large, it is infinite large. So you need to start at some point that is called source point, and at any point you can take m is how the max between x and y. How we are going to represent this means move to x plus m comma y, right? Means either you can move, right, at any point you have the x and y, you can either move to this direction or this direction. It means x plus m means it will be some value will be there. So if we'll say what you call coordinate, right? So x will go which direction? Horizontal direction, correct? Can we say that? And if we'll increase the y, so y will go which direction? This direction. Can we say that? So these two directions we can move either horizontally, if this is our x, right? You remember the coordinate system, right? So this is x and this is your y, right? So these two directions we have given. So at any point you have m, if you want to find, you will get max x comma y, which is max, that we have to take the movement, right? But before that, what you need to understand, why we are going to take the move, either will go this side or this side. So you have to check the value of if x is greater than y. If x is greater than y, it means you have to take the point x minus y, and if y is greater than, then you have to take y minus x, right? So you can find which move you have to take, because you will get the max here, right? Here m is the max between x and y. Okay, I hope you understand. Then it is saying return the minimum number of moves that is required to reach the target. If it is impossible, return -1. If you have still not understand, no need to worry, right? Just think that we have given a 2D infinite grid that I have shown you, and at a certain point that is called source, let's call it a source, right? That is, we have this one, right? These points we have given, and you want to reach at a certain point that is called target. So from here to, let's suppose we'll want to go here. If this is our source, this is our target, right? So we want to move, and how we are going to move, that we have to understand what is allowed. So we have allowed moves are, let's suppose from any point that is called x and y. Between these there can be any point, right? Let's talk about, this is a point we have given here, okay, and this point represents x and y. Can we say that? So you can move in 2 ways. Either you can move this one, x plus max of x and y. Can we say that? And another we have x comma y plus max of x and y. Means in this direction we'll move to right side, right, like this direction. But when we move this one, means we want to move upside. Easy, right? So all depends on who? Max x and y, means the maximum value of x and y. and our goal is to find the minimum number of moves, right, which is required to reach from source to destination, to target. If it is not, return -1. Is it simple or not? It's simple, right? Let's understand. So we have given the very first example like this, right? So example we have given is Sx equal to 1, Sy equal to 2, and target is 5 and 4. Let's call it the start. Let's suppose start is here 1 2, right? And we can represent like this, right? This is your 1 and this is your 2 and so on. Keep going like that, like we have here. Okay, so this is your grid, right? And each grid you can provide the points. This is your source point from where you will start, right? And this is the target point where you have to reach, right? That we have given already, start and target. So we are allowed to move what? This direction. Either you will go right and up. Which direction you will go, right? So when you are at where? 1 2, what is the max? X and Y take the max. 1 comma 2, you will get 2, right? It means you will choose to go up, correct? So 1 plus 2 plus 2, you will get what? 1 4. So you will reach 1 4 here, right? Then similarly, the another moves if you will take, you will have to find the max, right? Like you have find here, you find the max is here. You are getting the max 4 here this time, right? So if we'll represent this time we will reach where? 5 4 here, right? Like this. So with the two moves means when we are where? At 1 2, right? You can move to where? 1 plus 2. If you want to go, let's suppose what is the max is there? Max is 2, right? So either if we'll take the right move, let's suppose the right move is what? 1 plus 2. Can we say that? And another is 2. So it will become what? It will become 3 2. Can we say that? 3 and 2, right? So right move will take 3 2, and when we go for the up, we are getting what? 1 4. So closer target to this, which one is closer target? Which one you will choose? You will choose 1 4 or 3 2. Obviously you will choose the closer one. So this is your closer one. Can we say that? And that is why we have choose to reach here 1 4. Our target is different. Our target is 5 4, right? So this is somewhere we'll get, right? Means you have to take the move, right? You have to choose these two things we have to choose, right? So you have to choose the 1 4 one. So you will reach here. In the next step, when you reach the 1 4, right? We have to take two things. So max you will take 1 comma 4. Which one is max? When you are at 1 4, which one is max? 4, right? The 4 is max. So you can take two moves, right? 1 plus do 4. 1 is x and 4 is m, and already have y, we have already 4. Can we say that? This point. So this will go right because we are adding into the x, correct? And so from here, let's suppose if this is 1, we'll take, let's suppose 2 3 4, somewhere here 4, and here let's suppose 5, right? So from here you will reach to this point, and this point is nothing but 5 4. Can we say that? Like this you can represent. Okay, so when we have reached to somewhere, let's suppose it was 1 2, we have reached to 1 4. Let's suppose we'll reach somewhere here. Okay, 1 4. Let's suppose call it here. 1 4 will be here, right? Yeah, 1. We reached here, correct? In the very first move, right? So from here we reached how? Here, and then we reached here. But the target, from source to target, we have directly moved here to here. What we have taken? The move 1. This is your move 1, and this is your move 2. Can we say that? We can say that, right? And that is why we got 2 moves. And if you see that, we are getting the output to here. So this way we have to find the moves, right? And then we have to reach. So what is the intuition here? Intuition, we always move in the direction where it gives the maximum growth toward the target. So at each point we have max, we have to take x plus y. That will give you how far you can go. Either you will use increasing x or increasing y, and you will reach like we have reached to the we have reached in the 2 points. Okay, so let's understand the code now.
So let's understand the code here. Okay, so what we have given here, right? So first of all, we'll define the pair. Let's call x and y, right? And because the pair is look like a points, right? We can say that. So we'll take x and y because the points we have given is source and target we have given, right? And on the grid there can be multiple points will be there. So each pair of points will contain x and y. So whenever we'll initialize a point, right, we'll take x and y argument. So we have this it's called constructor x and y. So it will initialize the value. Okay, then in the very first step we need to check the conditions, and this is for the hasing, right? Okay, now why we will take the hasing? Because with the help of x and y, right, we'll create a unique hash value. Okay, and that is why we'll take the hash function here. This is our main method from where the given source and target points we have given, and we have to check the very first condition. We'll check if the source points are at 0, means no early return should be there. Okay, we'll check return tx is equal to 0 and ty is equal to 0, means source is 0 and target is 0. If both are 0, can we say that we'll get 0? Otherwise we'll return -1. Understand? So now we'll check if the source is greater than target, either x or y. It is greater than this, means it is beyond the edge. Can we say that? So these two are the edge conditions that you have to understand. Okay, means let's suppose we have given the coordinates we have given. Can we say that these are the coordinates we have given? Y, x, correct? And this is called 0 0. So 0 0 is a source point, right? And target, let's suppose target is also 0 0 here, means what we should return? We should return 0. There is no movement is there, correct? If it is any of these happening, right, we'll return -1. Okay, I hope you understand. Then understand this part. Let's suppose the source is here, point is here, and target is before this here. So if source is already on this point, let's call this point is 0, this is 0 1 2 3 and 4, and this is 1 2 3. Let's call this 3. Okay, so at this point let's call it 3 3. At 3 3 the source is there. Let me write here. So this 3 3 is our source. What is this? Source. And at certain position here, we have what? Target we have. And this is at, let's call it a 2. 2. Can we say that? It means Sx is greater than Tx. Give me a second. Tx. Correct? Because this is 3 and this is 2. So this is true, right? Similarly, we'll check what? Sy, it is greater than Ty. Correct? And this is also greater than this. It means both condition matches. It means there is no movement is there, right? Will return -1, right? Because it already here. Not required to come here, right? If it is coming here, no movement is required because it's already on the path. I hope you understand. This is very easy, right? So no early return we will do here in this case. Okay. Further, let's understand. So now what we will do? We'll create the queue, right? Because we are going to start BFS, right? And let's suppose we have given the target point is 5 4. The very first example we'll take. Okay, so target we have 5 4 and source we have given, let's take it here. Okay, so source is 1 and 2. Correct? If source is 1 and 2 and target we have this, right? Means Sx is 1, Sy is 2. Then we can say Tx is 5 and Ty is 4. Can we say that? We can say that these things we have to understood. Okay. Very first, what we will do. So the condition edge cases will give you false, right? Means no early return will happen, right? If it is matching, will return, right? Otherwise, we'll prepare the queue. So queue will take queue of points, okay? And we'll add the target points because we are going for the reverse, right? Reverse BFS will do, okay? So we will put the point target point where on the queue. So the queue will having first come first serve, right? It means we'll take a number of moves and we'll return the number of moves. Means we have to calculate this number of moves, right? Now we'll check the the BFS, right? How to do that? We'll do the BFS. We'll check on the queue. If queue is not empty, get the size. If size is greater than 0, right? Each time we'll do minus because we are reversing, right? We'll do minus. If it is still greater than 0, we'll poll the points and we'll get the points x and y. Means point p dot x, p dot y, because we have created the pair. Remember, so pair have two methods. Pair have two attributes x and y, right? So from there we'll get this p dot x and p dot y will get, and we'll get these 2 points x and y. So you will check the if we have reached to the source. Means if both are same, right? If both are same, it means number of moves is completed. Return the move. Understand? Right? Because we are doing what? Reverse from the target, right? And when the source matches with the target point, we'll say okay, we reached here. Otherwise, what we need to do? So this time, very first we have added on the queue 5 4. Let's understand the queue we have added here is a 5 4. Can we say that? Now understand, queue is not empty. Means what is the size of queue this time? Is 1. Can we say that? Yes, only one item is in the queue, that is 5 4. We have added on the queue. Now let's suppose we'll take in the queue like this. Okay, what is in the queue? We have queue here is 5 4. Can we say that? 5 4 in the queue. Now you will get the x and y, right? X is what? 5 and y is 4. When we'll reach this point, source value, right? Source is sx and this is sy. If it is equal to this, then we'll return number of moves. Fine. But this is not equal. This is not equal, correct? This x is not equal, y is not equal. It means the point that we have 5 4 is not equal to what? 1 2, because this is not equal to what? 1 2. Can we say that? Cut it directly, don't worry. Like this, can we say that this is not equal? Give me 1 second. I'm talking about these 2 points, because these are not equal, right? And so this is also not equal. So pair xy, that is coming from here, x comma y equal to, let's suppose 5 4. When we are comparing the values, it is not equal to, right? And the case will come. The very first case is this one. If x is greater than y, it means you have to take what? When x, we have to check x, if x is greater than y. What is x? X is 5. What is y? Y is 4. Is it true? No, right? So we'll check if x is greater than y, right? It means we have to check this. Means if we'll do x minus y, what you will get? X is what? 5. Y is what? 4. What you got? 1, right? And this one is we can say greater than equal to sx. Can we say that? It means it's valid. So you can add on the q. Add new pair. What is the new pair? New pair we can say is 1 comma 4. Can we say that? We can say that, right? So let me clean it. Okay, now understand. So we have added on the q. Now is new pair is 1 4, correct? So q will look like how? That there is one element, 1 point, and that point is 1 4. So how many moves is there? We have to take 1 moves. Can we say that? Yes, right? So 1 move will be there. So next level, what we will do? We'll check again, is q empty? Q having one element, right? That is 1 4. Now check, what is x? 1. What is y? 4. So check x not equal to sx, or y not equal to sy. So we can say 1 4 is not equal to 1 2. Can we say that? Yes, we can say that. Now we'll check the case, another case, this one. If x is less than y, 2 cases is there. First case we have checked. Now second case we'll check, because this is not matching, right? Y minus x, what is coming? 3, because 4 minus 1 is 3. Now check what? X is what? 1. Is it greater than equal to 3? No, right? So this is false, correct? And so we'll check the fallback check. We'll check y percent 2 is equal to 0, right? What is y? What is y? 4, right? So 4 is 0. So we can say y equal to 4. We can say directly y equal to 4, and it is an even, right? So just if you divide y by 2 equal to 2, which is greater than equal to y, and that is sy, and that is equal to 2, correct? So new point we can add on the q, will say is 1 and 2, correct? So now the q have 1 and 2. Number of moves become what? Now 2. So the next step we have to follow for 1 2, right? And this time you will check equality. If it is x is equal to what? Sy, is it correct? Yes. Then you will check y. Sy matches. Yes. Just return it. And so this moves will return it the value. I hope you understand, right? So that is why I think you will understand now, right? So the very first what we have done, we have defined this pair class. Let me zoom a little bit, right? Very first what we have done, we have defined the pair class. Then we have taken this has technique. So pair class, why we have taken x and y? Because each point will contains 2 point x and y. Can we say that? Yes, right? So whenever a new pair will create, this will take 2 argument, x and y, right? And so we can create the x and y, right? Then we'll create a you can say hasing, right? So this has will create you can say, see it, so each cells contains what? X and y, correct? Each cell will contain x and y as a coordinate, right? And we have to use in the BFS queue, correct? So when we'll take the x and y, so we will combine the x and y into a unique long value. So we can use it if we need to track the visited coordinate efficiently. And for that we have to take the has, right? So it will work internally. This is the Java concept, okay? Then we have what we have given, these points we have given, and then we'll check all the edge cases, right? So these edge cases, we have to find the what this function will do, find minimum number of moves x and on this from source to target, right? And we will use the reverse BFS, and so that we need to create the queue, right? So these are the edge cases. Don't forget that these are the edge cases to write. If source is 0 0, you can only reach 0 0, no moves will be there, correct? And if the source is already beyond the target, it is impossible. Understand? Then we have this queue. This queue we have to initialize it, and we will put that source first, right? Target will at the first, right? So we'll do reverse BFS. So start with the target point, that is a tx and ty, and move backward, right? So you have already added the queue. It is not empty. Size is 1. Check size is greater than 0. All the value pair means you get the p point and extract the x and y. Now check if the condition matches, return moves. If not, continue, right? So we'll take here, we have taken number of moves, right? So moves will be the count number of BFS level. So each step that is needed, that will count here, and will process the current level of the node in the queue, okay? Then level by level we'll traverse, we'll pull the current pair from the queue, and we'll find the coordinates x and y. Then we'll check the coordinates, right? If we reach to the source, we are done. We will not do anything, right? Otherwise we'll do the reverse move. So this is the code logic, right? Because we have to move, right? The condition is if x is greater than y, means we have to reverse. Remember, we have to reverse x plus m comma y, where m is the max of x and y, right? So we will go where? In the x direction, correct? And for that we'll do x minus y. If it is less than equal to y, then we'll check x minus y. If it is greater than sy, right? Then we are adding this one that we have just seen, right? New pair will be x minus y and the y. Then we'll check if x is even, divide it by 2 and check if it is greater than this. Then we'll do half of x by 2, and you will add the new point on the queue. Similarly, so give me 1 second. Never forget this concept, because without this concept you cannot implement the reverse move logic, okay? So you remember the function that we have seen, right? X plus m comma y, right? Where m is the max between x and y point, right? So that point we have to take, right? So you can get the x and y. So this x and y is coming from where? This x minus y comma y, right? Like this will come x minus y minus comma y, right? So it will only valid if x minus y is greater than or equal to what? This one. So we have to check that point. Understand? Means this x and y come from where? It will come from x minus y comma y. Only if the condition is x minus y is greater than the source. Correct? So we can take, so any point that you are taking at a certain point, any point you are taking, right? So it should satisfy this condition. Then we can only add that point onto the queue. Okay? If not valid, we will try divide by 2. If x is divisible by 2, it's even number, divide by 2, and then add a new pair x by 2, something, right? Means this is a fallback, means trying half x. That is why it is called binary search, right? If even. This is not a standard reverse step, right? Maybe an optimization, but not guaranteed value. Okay, so we can take like this. This is not given the logic, guys. Okay, so just think this is a logical thing. As a programmer, you have to think. Now understand, if y is greater than x, right? It means x is less than y. Then what we will do? We have the reverse of x plus y plus m, right? And for that we will get what? X and y minus x value. Only if y minus x is greater equal to y. Similarly, we'll go for the half y, right? We can say half y will get how? We'll check even number. If it is yes, we divide the half of y. Means we are trying to half y if no other valid is there, move is there, valid move is there. If there is no valid move is there, we'll try half. Then if this condition will not match, it means this condition will surely it will match, right? Means if x equal to y, right, you cannot reverse uniquely, try both 0y and xy. This is the brute force approach we'll try. Okay, for the else condition we'll check, we'll try both 0y and x0, both is the brute force approach. Okay, and then we'll keep continuing the move plus plus and we'll return minus 1. Okay, so it will increment the move count after finishing the current UFC level, so it will keep increasing. If the source never reach to the we will not reach the source, we'll return minus 1. I hope you understand. If you have any doubt, please ping me in the comment box. Okay, so let me summarize. So what do you need to do? Define the pair method, then has method, then you will have the minimum move method where you will define the edge cases. You will define the queue. From the queue you will we have added the first target, and reverse wise we'll get these values and we'll check if it is matching the condition. Then two condition was there we have given for the moves. We'll check the moves. If it is fine, we'll add on to the queue. Otherwise we'll check half of the queue in both sides, in x also and in y also. That is called fallback half, right? And then we'll try also if these are not possible, right? If these conditions are not possible, right, means we have to try another, that is the pair of 0y and x0. These points we have to check also. And then we'll move, each level, as you can see, each level will give you move plus plus, and then finally we'll return. If will not reach to there, we'll return minus 1. I hope you understand. Please pause this video and try to write time complexity and space complexity. If you are not able to find the time complexity, let me know in the comment section. I'll write there. Thank you guys. Thank you for watching this video. I'll see you in the next one.
Thank you guys. Thank you for watching this video. If you found this video helpful, please like, subscribe, and let us know what you want to learn next in the comment below. And thank you for watching this video.